Hello everyone, I'm Karthik from ITA section and my roll number is 1230. Today on concept video my topic in DMS is about acid properties in dbms. So let us know what are acid properties and what are the types in dbms. Let us know further slides. Acid properties in dbms. A transaction is a single logical unit of work that accesses and possibly modifies the contents of database. The transactions access data using read and write operations. In order to maintain consistency in database before and after the transaction, certain properties are followed. These are called acid properties. So the slide is about a transaction is a single logical unit of work that accesses and possibly modifies a content of database. In the content of database, transaction accesses data using read and write operations. So these are all called as the acid properties. Let us know some more information in further slides. So here we can see the chart of the acid properties in dbms. So what are acid properties? Let us know briefly. First, A means atomicity. The entire transactions takes place at once or doesn't happen at all. So coming to next, C, its consistency. The database must be consistent before and after the transaction. And coming to the next, I, isolation. Multiple transactions occur independently without interference. And coming to D, its durability. The changes of a successful transaction occurs even if the system failure occurs. So these are about acid properties. We have known every abbreviation of each letter. Coming to A, the entire transactions takes place at once or doesn't happen at all. And C, the database must be consistent before and after the transaction. Coming to I, multiple transactions occur independently without interference. And D, that's the changes of a successful transaction occurs even if the system failure occurs. These are about the acid properties. By this, we mean that either the entire transactions takes place at once or doesn't happen at all. There is no midway, that is, transactions do not occur partially. Each transaction is considered as one unit and either runs to completion or is not executed at all. It involves the following two operations. Uh, in this slide, we have discussed the entire transactions takes place only once and doesn't happen at all. This means atomicity, and there is no midway. Transactions do not occur partially, and each transaction is considered as one unit and either runs the completion or not executed at all. Involves the following two operations. Let us see what are those two operations. So the first operation is abort. If a transaction aborts, changes made to the database are not visible. Let us see an example. Before x equal to 500 and y equal to 200, transaction T occurs. We get two different parts. First transaction is T1 and the second transaction is T2. Coming to the first transaction, we have to read x equal to x minus 100, write x. So after transaction we get 400x equal to 400. Before transaction it's 500 minus 100, that is 400. Coming to the transaction 2, read y equal to y plus 100. So before transaction we have that is 200, and while continuing the transaction, y plus 200 to y plus 100, 200 plus 100, that is 300. We get y equal to 300. This is after the transaction values. This is about abort. So commit. If a transaction commits, changes made are visible. Atomicity is also known as all or nothing rule. Consider the following transaction: T consists of a T1 and T2 transform of 100 from account X to account Y. This is the question which we have did in the before slide. So this is about abort and commit, and the example on this: if the transactions fail after completion of T1 but before completion of T2, then say after the write X but before write Y, then the amount has been deducted from the X but not added to Y. This result in an inconsistent database state. Therefore, the transaction must be executed in its entirety in order to ensure the correctness of the database state. This slide is about the transactions, how they are made, and after the transaction fail after the completion of T1 but before the completion of T2, what the case we have to do. Then the amount has been deducted from X but not added to Y. This results in an inconsistent database state. Okay. Therefore, the transaction must be executed in entirety in order to ensure the correctness of the database state. So let us know what is consistency. This means that integrity constraints must be maintained so that the database is consistent before and after the transaction. It refers to the correctness of a database. Referring to the example above, the total amount before and after the transaction must be maintained. So total before T occurs, that is equal to 500 plus 200, that is 700. After T occurs, 400 plus 300, that is equal to 700. Therefore, the database is consistent, and inconsistence occurs in case of T1 and completes, but T2 fails. As a result, T is incomplete. So this is about consistency. We have seen what is consistency in this slide. Let us see some more information about the various others. Isolation. This property ensures that multiple transactions can occur concurrently without leading to the inconsistency of database state. Transactions occur independently without interference. Changes occurring in a particular transaction will not be visible to any other transaction until that particular change in the transaction is returned to memory or has been committed. This property ensures the execution of transactions concurrently will result in a state that is equivalent to a state achieved this were executed serially in same order. This is about isolation. So it discusses about the property that ensures that multiple transactions can occur concurrently without leading to inconsistency of database state. So transactions can occur independently without interference. Changes occurring in a particular transactions will not be visible to any other transactions until particular change in the transactions is written to a memory or has been committed. So let us see an example. Let x equal to 500 and y equal to 500. Consider two transactions T and T. So while coming to the x, read x equal to x into 100, write x and read y equal to y minus 50 and write y. And coming to the other transaction, read x and read y, another z equal to x plus 5, write z. Suppose T has been executed till read y and then T starts. As a result, interleaving of operations takes place due to which T reads the correct value of x but the incorrect value of y, and the sum computed by the second transactions x plus 5 equal to 50 and 0 plus 500 equal to 50 and 500 is thus not consistent with the sum at the end of the transaction. T x plus 5 equal to 50 and 450 equal to 50 and 450. This results in data base inconsistency due to the loss of 50 units. Hence, the transactions takes place in isolation. Changes should be visible only after they have been made to the main memory. Coming to the last one, durability. This property ensures that once the transaction has completed execution, the updates and modifications to the database are stored in and returned to disk, and they persist even if a system failure occurs. These updates now become permanent and are stored in non-volatile memory. The effects of the transactions thus are never lost. Some important points to be remembered. Property reasonability for maintaining properties, atomicity transaction manager, consistency application programmer, and isolation concurrency control manager, durability recovery and manager. The asset properties in totality provide a mechanism to ensure the correctness and consistency of a database in a way such that each transaction is a group of operations that acts as a single unit, produces consistent results, acts in isolation from other operations, and updates that it makes are durably stored. Thank you. This is about asset properties in dbms.